Well, thank you, everybody. I'm very excited to be back. For those of you who were last year, I did a talk last year when I was a CTO at the Daily Mail, mostly focusing on how we worked, a little bit about how we use Node, but mostly focusing on how we worked. This time around, I've switched camps. I'm now working for a company called TES. We're global because it says so in the name. TES, for those who don't know it, basically we're a business that provides an entire kind of end-to-end lifeline for teachers. So we're a 115-year-old educational publisher. We publish a magazine in the UK, run the Times Higher Education magazine, the World University Rankings, a whole swathe of stuff. And I'm basically using the next few years to maybe improve my karma after spending 3 years at the Daily Mail. So fingers crossed that works. So obviously last year I talked about how we worked. And I think it goes without saying for anyone who knows me that we'll be doing the same sort of things at TES as we sort of flip the organization around. But what I'm actually going to talk about today is, obviously I'm in the microservices track, so I'm not going to talk about organization, I'm going to talk about what we're doing on microservices. So to consider what we do, I've kind of touched on it a little bit. We're this kind of end-to-end lifeline for teachers. So we offer everything from recruitment, so job advertising, through to news. We do a number of publications. We have a resource bank with over 800,000 free teaching resources where teachers can share PowerPoints and lesson plans, all sorts of amazing stuff. We do teacher training, career advice, salary checkers. We've got communities, forums, literally everything that you can imagine that a teacher might want to interact with on a day-to-day basis, we've got somewhere on our site. And most importantly, those things are all intermixed. So they're not sliced neatly up into different sections or on different domains or as different products. Basically, it's kind of a mishmash across the entire site. If you're in the news section, you'll see job adverts and links to resources that might be relevant. It's all intermixed. And that's not unusual for a very, very content-rich and content-oriented business. And it's a good thing. It's one of our strengths. But of course, that comes with a lot of challenges from a technology perspective. And I'm very, very lucky in that my predecessors obviously thought long and hard about this challenge. And they spent about 14 years. They started building this in 2001. They spent 14 years tackling this challenge, and the solution they came up with left me in a very good position. They put everything in one box. So I have a massive .NET monolith. At the Mail, I inherited Java. Here it's .NET. It's exactly the same. I think the nuances here that make it slightly more interesting is that they elected to take a beta version of a .NET CMS, a proprietary one that we pay for, from 2001, and we've since built our entire business on that code base. And it hasn't changed in any meaningful sense apart from gathering more code since then. So it's pretty spectacular. It feels like Groundhog Day. So the good thing about it being Groundhog Day is I have the tools in my tool bag to fix it. So unsurprisingly, I'm going to take a similar approach that I've taken before, which is to break it into chunks. Attack this thing, slice it up, try and break it into small pieces and fix each of those small pieces. I'm very lucky. One of the reasons I got brought on board was to help transform a key part of our business. And that key part of our business is this platform that we have that allows teachers to share content. It's an amazing kind of community-driven, completely user-generated, completely free platform. Gets a phenomenal amount of traffic, as you can imagine. From an SEO perspective, we have like 800,000 resources for every subject, covering multiple curriculums in the US, the UK, global. So the kind of search equity around that content, in addition to the fact that we have 100 years worth of news online, is immense. So we're relaunching that entire platform. We're relaunching it not just as a free service, but we're also introducing a set of features that effectively turn it into a double-sided marketplace, allowing teachers to actually sell higher quality content to each other. So it's a really interesting project. But basically, it's the project that we're going to use as the sort of the pilot for basically fixing the architecture. So what does it look like? This is a mock-up of the sort of a new resource page. Looks pretty simple. I think what's interesting about this page is, despite the fact that it's simple, it actually has a lot of intermixed concerns, right? And a lot of intermixed functionality, which is just a tiny example of what we have across the entire site. So if we have a quick look at this page and what's on it, first thing you'll notice, we have site branding, site navigation. This is exactly the same across the entire site, whether in the jobs section, the community section, the news section, whatever. And obviously, it doesn't really make sense for this resource page to own the capability and the functionality and the logic to render the navigation and the master. It doesn't make sense. The next bit, the resource information itself. I keep forgetting I'm not allowed to look at the slides. Basically, the core information about the resource, summary, title, the taxonomy tags, other things, the ability to download. This is more sensibly part of the resource page. Next up, we have reviews and comments. So people can comment on resources, say, fantastic, I used this in my 4th grade class, I'm a superhero. They obviously change at the rate that you get reviews in, which is a very, very different rate than the rate at which the summary itself changes, which clearly only changes when the resource itself gets edited. The final piece, or 4th piece, is the user profile. So again, this is something that changes at a different rate to the resource itself. A single user will have multiple resources. It also changes based on your social interaction with that author, because you may follow them, you may have liked them. You know, there's a range of kind of traditional social features linked to that author profile panel. And then the final piece, which is, I have no idea why this is hidden, is a kind of more like this recommendation type thing. So if you arrive from Google and you're looking for a specific piece on Shakespeare, then this will show you all the other things that typically people who download this would probably download as well. So even this inherently simple page, which in times gone past, you would literally just build an app, write a single controller method that probably had the responsibility for rendering this page. Within that, you'd go and get all of the data that you needed and just render it. Job done. And of course, the problem that we have is that this just exists as a small microcosm within a much larger application. And as such, if we went that route, we'd end up with a whole swathe of applications that duplicated all this functionality. So we're not going to do that. We're going to break each of those pieces into different microservices, okay? So basically, we have a set of really simple ones. And you could probably take a different slice at this. We always slice this up effectively based on business functionality, nothing to do with the technology. So here, masthead navigation is a broader corporate function. The resource summary is inherently linked to the resource. Reviews is actually something generic, which we apply not just against resources, but also against things like jobs or courses or other things. So it's a more generic functionality than it first appears. We also have the author and social panel. Again, this is a sort of feature that appears across the site, because that teacher may also be creating blogs in our community area. And then recommendations, again, this is a fairly generic function where we may actually want to put recommended resources on various hub landing pages for specific subjects. Yep. Brilliant, fantastic. We can use all the stuff that Richard just talked about to build amazing separate microservices. We get teams split up, working on each of those, fantastic. But there's one big challenge, and it's a challenge I think that Richard alluded to, which is how do we put them all back together? Because at the end of the day, the job of us as technologists isn't to build 5 microservices. The job is to build that page, okay? So how do we put them all back together? I'm going to summarize my view of the 4 probably most common techniques. I think they wrap up pretty much all you can do. The first route is client-side, okay? Render a fairly boring static page, and then client-side, make calls back to an API, get each of the fragments, render them on the client, job done. The problem with this, of course, is this page has an incredible amount of search equity. We can't render it on the client. I think we could render fragments of it on the client. So for example, the reviews section, Google doesn't care about it, and in many respects would prefer it if we didn't include it in the resource. So that's a good example where we could actually render that single fragment client-side. Perfect. The second option, which is probably the most common, is the one that Richard talked about, which is, despite the fact that you've broken these things into microservices, you go and build a front-end server. So this server's entire responsibility is to actually call all the other microservices, pull out the data, render the page, job done. The problem with this, of course, no matter how you build it, is you've basically gone and created a single point where if you want to change any one of those 5 pieces of functionality, you also now have to change that one. So even if it's not a monolith, even if it's still a microservice, the reality is you've just gone and created another choke point. So you can't have those 5 teams working independently again, okay? The other thing is you'll end up in that server building a whole pile of patterns to make sure it stays up. You know, Richard talked about the idea that, you know, the different microservices get deployed maybe with different levels of testing. So obviously what you can end up in a situation is someone changes the masthead service under certain scenarios, it means it falls down. If it falls down, the entire page falls down. That's not great behavior. So there's some alternative approaches to that. Another one, not often used these days, but still there in all the kind of Apache, Nginx and everything else, is a feature called server-side includes. Server-side includes is a directive. You can basically stick it in HTML, switch it on in Nginx or Apache, and it'll basically make a call back as it's parsing the HTML on the way through and grab a fragment of HTML from whatever service you tell it to, compose that into the response and serve it to you. Okay? Really neat trick. The problem with it is it's quite challenging and difficult to control, for example, how it might cache that fragment, what it does under certain failure scenarios, how does the page itself respond when any of the one fragments dies. So there's some alternative views of this. There's another approach which is common within things like Varnish and also on Akamai, Fastly, those sorts of CDNs, which is called an edge-side include. ESI is actually a standard. I think you can read all about it. It's incredibly rich in terms of what you can do. It's not just a language where you can include other content within a page, but there's actually logic and other things that you can do within it. You can interact with cookies, set cookies, do all sorts of stuff. So edge-side includes is what we used at the Daily Mail. We use them extensively across the site. And obviously at a site that high volume, you need to be able to separate the things that are specific to a user from the things that are generic from a caching perspective. Otherwise, you'll go out of business with the amount of servers that you have to run. Edge-side includes are great. They do have a problem. One of the problems is that they pollute your HTML with shed loads of pseudo HTML markup. It's pretty horrible. It was all written, the standard was written when XHTML was all the rage. It's also challenging in that both, the only thing that really supports it is either Varnish, great bit of kit, or Akamai, which basically if you use Akamai at any scale, you'll also be out of business. So they're broadly the approaches that you can take. I think the most interesting thing is that the last two are kind of a different take on it than most of us would think naturally, which is, most of us when we think of microservices think of JSON APIs, right? A service that responds to, like a RESTful service that responds to JSON, returns JSON or receives JSON messages or posts JSON messages. The last two kind of hint at a different approach, which is an approach where a microservice will actually give you back HTML if you ask for it. And I think this has caused a lot of debate within my team at various points. Is it appropriate for a microservice to also render its own HTML? I think the answer is categorically yes, if you ask for it. So the service should also render JSON if you ask for JSON, but there's absolutely no reason whatsoever that if you ask for a HTML representation of an author profile, that the author service shouldn't produce that for you. Obviously, it's only producing the fragment rather than anything more complete. So we took a different route. And I think in terms of those reasons of why those four things didn't work for us, I've got a few blog posts that describe that, so if you're interested or want to chat to me later, I can talk more about it. So we took a different route. So we built a microservice whose entire purpose in life is doing this sort of composition. We called it Composure because we had to come up with a fancy name, which stands for Composition Proxy. And basically, all it is a piece of Express middleware. It actually connects, like you can run it, the sort of smallest, simplest app is basically just a connect app, very, very small. That basically the idea is very, very simple, which is you put this as a lightweight proxy in front of your backend services. There's two types of services. One is a backend that basically serves HTML. So in this model, it would effectively be best to be thought of as the kind of the core layout of your page, so the framework of your page. That could either be a static file or it could be a CMS, right? Within that page is basically a markup that allows Composure to come back, very similar to ESI or SSI, and actually interact with each of the microservices in a simple declarative way and retrieve the content and render it. It also provides a range of other things in terms of caching, circuit breakers and others, which I'll talk a little bit about. So what does it look like? A Composure include basically is HTML. We just use attribute definitions. So literally you go and put this into a page that's passed through Composure. You can see very simple how it works. There's a URL declaration. There's a server that's defined within config, so it won't go anywhere to get content. It'll only go to a set of servers that you've defined. It can interact with the URL that's coming in. So if you define regex patterns, it'll pull resource IDs and other things out of the front URL to basically pass that through to each of the microservices. Yeah. It lets you programmatically define the cache key that goes into Redis, and also timeouts, other things. There's a whole pile of other stuff it lets you do in terms of ignoring error codes and other things, but it's actually very, very simple. The other advantage is it lets you put HTML inside the element that effectively acts as fallback content. So if that service doesn't respond in a timely manner, it'll just serve whatever's inside it. Okay? So it's simple, it's declarative. There's a whole range of different kind of logic things that you can use in it. The language it uses is just mustache, so you can even use simple logic declarations. So for example, if there's something in a query, if there's a query parameter, you can actually change the URL dynamically, et cetera, et cetera. So in this model, the microservices themselves, they're fairly simple. They have to serve HTML, right? I mean, this is simple kind of composition at the HTML level when you're rendering a page. So they should serve HTML. They should fail fast, okay? And they should also honor a CDN header. And this is important when we think about composition of HTML, because one of the challenges that you have is that when you pass back the HTML rendering to the services, they need to know things like, where are the images, where are the static assets, right? Suddenly that responsibility, which typically sat in your front-end app, now has been pushed down a stack. So you need to pass that information through into each of the services, or have it as configuration that's globally shared, just so that all the URLs and everything else just kind of work normally. In that model, Composure will pull together, compose, and cache the fragments if you tell it to. If you tell it you don't want to cache the fragment, it'll just pass it straight through on every request. It'll always serve last known good or default. So if a service has been working perfectly for the last 24 hours, but then it suddenly has a failure, rather than just serving a massive failure on your site, it will serve the last known good fragment for that section. So your site can be fairly broken underneath, but it'll still appear good while you're fixing it, which, trust me, is an incredibly good thing. The number of times the Daily Mail was completely down and nobody noticed was amazing. I can tell a story over a beer over the 10 minutes before the Olympic opening ceremony, where literally our entire platform was down just before. We brought it back up a minute before the opening ceremony started. So Composure is also, it's kind. So there's a simple circuit breaker implemented. If your services start dying, start struggling, rather than just hammering them into the ground, it'll apply a circuit breaker pattern. Again, it can be configured. And again, it's this idea that says, if things start struggling, you should be kind to them. Back off a little, report about it, but actually don't hammer them into the ground and bring the whole system down. And also be communicative. So there's hooks for sort of logging, stats.d and other things, so you can see exactly what it's doing. For those paying attention, there was an overall rating in the resource summary. Did anybody notice? No. Good. Now, obviously, overall rating is actually a product of the reviews, right? So there's a question here: how do we put overall rating in the summary? The answer is this is where we use some of the messaging. Reviews and the resource itself have completely different data stores, but every time we get a new review, we publish a message that says, here's a new review, and here's the current overall rating for that resource. We just persist that against the resource in the resource service. So the resource service can render its own fragment completely independently of reviews. If reviews goes down, you can still render the summary and the overall rating. But obviously, if you don't get any new reviews, that section would close up. So I'm actually running out of time, so I'm going to speed up for the last bit. But this has a second question. By the way, Composure is completely open source. It's on our GitHub repo, so please have a look. The second challenge, and this is a challenge we had at the Mail, but we didn't solve, is what you do with all the static assets. So we're now in a world where we've effectively distributed the ownership of the HTML for each of those fragments down to the underlying services. The reality is the actual JavaScript and CSS that's inherently linked into that HTML should probably live there too from a versioning change control perspective. What that then does is it creates this challenge, which is, but I'm actually serving a site. I need to bundle all that together and serve it with the overall application. So we've had a couple of attempts at this. The first attempt, I wrote once over a weekend when I was traveling. I tried to convince the team it was a great idea. It's kind of, this predates Bower, but it's kind of a Bower-like solution where you kind of take these assets from each of the services and kind of push it into a central repo. I couldn't convince the team that it was a good idea. They just couldn't, they just wouldn't accept the idea that I would pull the HTML and CSS and JavaScript out of their amazing Clojure code base and put it somewhere else. So I lost that battle. And again, I can talk about that if anybody's interested. At the Mail, we had a second attempt, and this is sort of a step back from that first. And the solution here was simple, which was okay, what we'll do is we'll take all those things out of the microservices and we'll put them in their own project and then use grunts to basically manage their life cycle. This kind of works. The problem with this is you basically create a new monolith from a deployment perspective. So you're in a situation now, if you want to change a specific function or a specific piece of functionality, you now have to actually change not just the service, but you have to now go into another repo, change the corresponding JavaScript and CSS, do the whole bundling and deployment, and you have to synchronize that deployment, which, as Richard alluded to, can be a bit of a pain. And if you're working across multiple teams, suddenly this project becomes a single point where you have to reintroduce things like branching and merging, and that's definitely something you don't want to do. So that's where the mails still are today. Thankfully, I learned something from that. So at TES, we're taking a different route. We've built a tool that's called Bosco. And the best way to think about Bosco is it's a solution that allows you to leave all of your static assets inside the microservices. So when you're doing development against any of those fragments, you can leave them exactly where they are. But because you're building a system that's made up of a composition of services, it effectively rolls across the top and acts as a bit of a helper that manages things like minification, deployment of those assets, okay? So the way it works, it's a command line tool. It's linked into your GitHub organization. So the assumption is, like us, many people here use a GitHub organization or something similar. And within that organization, you have teams. Inside those teams, you'll have all the repos that those teams typically use. So for this resources project, I think we have about something like 50 GitHub repos, everything from kind of Docker images for various infrastructure components through to the actual services themselves. And the way this works is really simple. You basically install Bosco, go into a working folder, go Bosco clone install, and it'll basically pull down all the repos in that team, clone them all, run npm install across all of them, so that you basically have a workspace for a brand new developer where you can basically just get going straight away. I know I'm running late, so I'm just going to keep zooming. What it effectively does then is you can define a config file in each of those services if they have static assets. Think of this a little bit like effectively just sort of a grunt file, I guess, in that it tells Bosco where are the static assets in this service, interacts with existing build tools. So if the services use gulp or grunt or anything else, it'll honor those. It isn't replacing them, it's just aggregating them. And it's got some neat features. So you can run Bosco CDN. It'll minify all the assets. Bring all the assets together and serve them locally. It'll serve fragments. So in this instance, there's a fragment here for the top JavaScript. Obviously, what we do with that is we use Composer to pull it into the page. So you can basically keep Bosco running. It'll serve up these fragments that represent all your static assets. You can then minify it, in which case it'll create a minified bundle. It'll create a manifest telling you what files were in the minified bundle, as well as source maps. Again, you can run that locally, but you can also push that up to a CDN. So in this model, you could push it up to S3, for example, and then you can see there a very simple include where you could say, hey, include that script in my page. Basically, it solves the whole kind of versioning and inclusion problem when you're building a bigger app based on a set of underlying services. Sort of finish off, I'm 2 minutes late. Our architecture looks a little bit like this. You have the user. I'm going to ignore all the load balancers and other things. They come in, they hit Composer. It grabs the static HTML from the back end, composes all the services together, renders the page. If there's any further interaction, like posts of a new review or any AJAX, they typically go straight to the microservice. We just route that at the load balancer tier. There's no point passing that through Composer. And then all the assets get kind of bundled up by Bosco and placed out onto CDN. So if you want to know more, come and talk to me. There's a blog post on it on my blog. Otherwise, more than happy to talk to anyone if you've got any questions. So thank you.